So if you find a lot of common minerals, can you tell the age? So scientists have multiple ways to do that. One of the ways is something called potassium-argon dating. So many minerals like mica or feldspar have some potassium in them. Some of the potassium occurs as potassium-40, which is radioactive, and that is actually good for here. So if something is radioactive, its atoms will decay into atoms of another element, and the atoms will change. So potassium-40 is not the most common one. It's not that common. It's not a common isotope, but it exists. And it decays into either 40 calcium, which happens around 89% of the time, and it also decays to 40 argon-40, which is a gas, but it's not that common. So the bad thing about using calcium, even though more of the potassium-40 decays into it, is that calcium is a very common element. Calcium-40 in particular is the most common isotope of calcium. So it won't be good, because then you see will already be some and quite a lot of calcium in the original rock that you're trying to measure, probably, and the increase will not be that much, so it will be harder to calculate than if you use the dating with argon. So let's see how the dating with argon works. So the dating with argon works so originally there would be a certain amount of potassium, and then there won't be a lot of argon, because argon is noble gas and it's not that common in rocks. But once the potassium decays, the argon will be trapped in the structure of the rocks unless it is molten. So the argon will be trapped and then it can't get out, and as more potassium changes into the argon, the potassium amount will decrease and the argon's amount will increase. So that is an effective method, and then based on that, the scientists can calculate the age of the rock. So that's how they do this. You got it now?